Welcome, everyone. My name is Heather Knoll, and I am the program coordinator at Sustainable Woodstock. Founded in 2009, Sustainable Woodstock is a not-for-profit community and environmental action and education organization. And our vision promotes vibrant, inclusive, thriving communities where we live sustainably now and in the future. This event is a part of our Green Drinks series. Green Drinks are social events to connect people who have similar interests. We invite local nonprofits, businesses, and individuals to make a short presentation to share their sustainability and green initiatives in our area. And next month, we will have an in-person event on home electrification at the Norman Williams Library with the Vermont Energy Education Program. And that will be on Saturday, February 24th. Now I'm excited to introduce you to everyone joining us this evening, and we have a number of people here tonight to both present and also help answer questions following the presentation. Sustainable Woodstock is hosting this event to discuss the new school building proposal, specifically the net zero aspects of the building. We support a new net zero school building as a step toward reaching Woodstock's net zero emissions commitment. And we have a representative who sits on the advisory committee for the new school, Todd Kortekamp, and he is here with us this evening. Ginevra Wetmore, Sustainable Woodstock's executive director, is also joining us tonight. And our presenters for this evening are Ben Ford from Mountain View's Supervisory Union and Eric Gebrian from Consulting Engineering Services. Thank you all for joining us tonight.
Great, Heather, do we take it away?
Yes.
Okay, great. Well, let me introduce myself a little bit more. Thank you for that. So my name is Ben Ford. I'm a representative to the school board, and it's the Mountain Views School Board. We've renamed the school district. The kids in the district did that last year, just trying to find something a little more descriptive of the towns in our district. But I am the vice chair of the board. Also with us tonight is the chair of the board, Carrie Bristow, I see. I also serve as the chair of the finance committee and the chair of the new build committee. And just by way of overview, what I'd like to do tonight is just talk about an overview of the process of kind of how we got to where we are in terms of the plan to build a new school building to replace the existing middle school and high school building in Woodstock, and then give you some background on how we arrived at the decision to pursue a net zero facility, and then turn it over to one of our engineers from our architectural team, Eric Gebrian, and he's going to provide some more details on the HVAC systems and the plans to achieve net zero over time. And then we could do some Q&A after that if people have specific questions about those goals, or if there are other questions about other aspects of the project. A lot of people are interested in the financials and the district's plans for mitigating tax impacts, for instance. I'm happy to go into as much detail as people would like about related topics. So with no further ado, I will share my screen and talk about the steps that we have taken to date. Can everybody see my screen okay?
Yes.
Great.
Yes.
Okay, so this goes back a ways. We've been at this for about 8 years. And in 2016, this is before I got on the board, but we recognized that, the building wasn't really what it needed to be. We were starting to, not starting to, but for many years had experienced a lot of systems issues and problems with the building. The high school building was built in 1958, and the middle school addition was put on in 10 years later in 1968. And at the time, the building was constructed out of inexpensive materials like concrete blocks and fixed concrete panels that have kind of rebar running through them. Most of the ceilings in the middle school wing have those fixed concrete panels. And as a result, as the building has begun to kind of break down, those materials are really only good for about a 40-year lifespan. So, building probably should have been replaced, sometime in the 2000s, early 2000s. Anyway, by 10 years after that, the Buildings and Grounds Committee authorizes a group of community members to perform an evaluation. We were lucky enough to get 150K in funding and put out an RFP and hired an architectural firm to do a 21st century school master plan at that time. And that was a process that went for a number of years. A baseline facility study, visioning workshops, the project goals were all established, at that time, and lots of sessions with teachers and administrators and community members, students, to really kind of understand what it was that we could potentially do with a new facility. We wound up getting another $200,000 in 2019, again, all in private funding for that planning work. And we established this configuration committee of the school that was there already, but that was kind of the new build committee was a spinoff from that committee. And at the time, the biggest concern was really around financial feasibility. The financing mechanisms were pretty much a mystery. It had been a long time since anybody had built a school building in Vermont, and that was what we were all about at that time. By 2021, we got the first costing for the project that came in at $73.5 million. That was from Whiting Turner, the construction firm that's doing the Burlington High School project currently. And interestingly, we also had to do an enrollment study at that time as part of kind of state approval processes. And the New England School Development Council said, we've looked around Vermont, most areas of the state are seeing declining enrollment, but not your district. You're projected to gain 120 students over 10 years. Apologies, that's a typo on the slide there. It's by 2030. And that certainly was borne out by a lot of the kind of pandemic factors that were in swing, a lot of migration, people, trying to get into our communities. We certainly saw a lot of that at the time. In 2022, we brought on a part-time fundraising manager, and to date, we've raised $3.5 million in pledges, and that's really part of that plan to mitigate tax impacts. And then in that same year, I wanted to show everyone. This is kind of interesting. There was we were getting pretty serious about the designs of the school, right? Having costing information, and a group of students at Woodstock High, and this is the Earthbeat Student Club, right? Wrote this letter to the Standard, and it was great. It really pushed us in our thinking. And I guess I'll just read these couple paragraphs. It's, we're aware of a hybrid plan proposed for heating, cooling, and energy systems in the new school, designed to foster student well-being and encourage collaboration. This hybrid design ensures a school that would utilize traditional heating and cooling elements and or heat pumps and add renewables such as solar to obtain a lower carbon footprint. We've begun to feel excited as more conversations are happening surrounding this plan, but what if we could do better than a hybrid model? Taking the plans one step further into becoming net zero is in line with our student values, and it would inspire future Woodstock students. A net zero school would mean the building would run solely on green energy, slowing our school community's contributions toward the degradation of our planet. If we are to build a new school, we should do it right. They said, let's hold Woodstock and the greater Vermont community to the standard of proactivity. Striving for a net zero school is consistent with our legacy and the climate issues we seek to solve today. And then they go on to talk about how, Union Arena across the parking lot was the first net zero hockey rink, and that we should be the first net zero school in Vermont. So as the new build committee, we kind of took that as that challenge to heart. And as we, the next year going to 2023, there was the first time we went to the public for money on this project was the architectural fees of $1.5 million, and to bring on the construction management firm that 1.65 million total. And that passed really without much fanfare or promotion by the school board. About 58% of voters voted yes on that. Now, not a whole lot of impact to taxes at that level, but we saw that as a good indicator of interest in our approach to the project. And so from there, we really went into high gear last year, a series of meetings through, with the architects, the design team across, all kinds of kind of functional areas. And one of those was a sustainability group that was specifically interested in selecting the HVAC systems for the building. And initially we had these options, and Eric, this is a slide that Eric had prepared at the time. We were looking at essentially all geothermal systems, hybrid geothermal or air source systems, and then all air source systems. And we had initially landed on this all geothermal option in this column. Unfortunately, when we brought on PC Construction in October of 2023, and they did their first run of costing, we were kind of bracing ourselves for a degree of inflation from this 73.5 million we'd seen the year before, and kind of set expectations with the community at like 80 to 85 million. Their first costing came in at around $125 million, right? And we were, sticker shock. You saw a lot of this inflation in the pandemic. We weren't really prepared for that. And as a result of that, we said, look, we need to make some serious decisions in order to keep this project alive. If it comes in, that far north of $100 million, it's going to be sunk. But by the end of our value engineering sessions, we were able to get the project, and this is all the site work, all the furniture, fixtures, equipment, soft costs, permitting, all in down to $99 million. But as part of that, we needed to revise our approach on the HVAC system, not going back to that hybrid system that the students, the Earth Beach students, were concerned about, but going with the hybrid option that Eric will talk about now. I'll switch over to these other slides. So Eric, do you want to maybe introduce yourself and jump in here?
Sure. Yeah, and can everyone hear me? Or at least Ben, you can be the representative of making sure my audio is okay.
Yeah, loud and clear.
Okay, great. Yeah, I'll wait till you get it up.
Yeah. Sure.
So just while we're trying to get that maybe a little bigger on the screen. Yeah, Ben, that was an excellent overview of kind of the evolution of how we got to where we are today. And just to add a little further clarification on the original hybrid that the students had concern with, and I think rightfully so. The original hybrid we had proposed, and this was going back a few years, was not a fully electric building. I would call it a mostly electric building, and we were still, again, mainly for cost saving measures, proposing some level of fossil fuel boiler system to kind of add and supplement throughout the year as kind of a backup. So that was kind of, it was a hybrid electric, hybrid, still some fossil fuels. So now we'll kind of go through where this has evolved into now.
You might show my page. Sorry.
Your show, the page I see is the other one, not the one you want to show. I forget.
This is like the one I want to show. Okay, sorry about that. Let me,
no, that's okay.
Yeah, hold on, let me do it.
Mine always goes backwards on me whenever I share as well.
Yeah. Let's see.
This is supposed to be the like back of house view of the PowerPoint.
Yeah, I had sorry guys, I had a projector. Sorry, not a projector, but a separate screen. This should work better now.
There we go. All right. So just to start off, real broad brush, the goal here that we've all set for ourselves is to get to net zero, which just very quickly, net zero means that the building on site in a sustainable way creates as much energy as it consumes, and typically that takes the form of solar panels, either on the roof of the building, over a parking lot structure at grade somewhere, but photovoltaic solar panels are almost 99% of the time the way that we generate electricity sustainably on a building or a project site. And so what that means is to truly be net zero from an energy perspective, the building has to be an all electric building. You cannot unburn fossil fuels once you've burned it. And so the theory is to be truly net zero and truly sustainable. Everything in the building is electric, and that's from the cooling systems, the ventilation systems, the heating systems, domestic hot water, the kitchen, everything that uses energy in the building should come from an electric source. And then the idea is that you put PV panels on the roof or elsewhere, enough to kind of net yourself out to zero. So that's what a net zero building is, and that's the goal. It's a very comprehensive process to get there. So, you know, number one goal of a net zero building, it can take an extraordinary amount of solar panels to offset the entire energy use of a middle school, high school. So step number one is reduce the overall energy use of the building as much as possible. And there's a number of different ways we do that. The architect on the project is excellent and has done this exact process many times before. And the first thing is to start with the architecture of the building. And that's kind of the first bullet point. On the passive side, take advantage of the sun, site the building so that you have passive solar heating in the wintertime, but then you're shading the sun as it goes higher in the sky in the summertime. Make sure that the envelope of the building, so that's the windows, the walls, the roof, the insulation, the performance is as good as it can be from an insulation standpoint, and also air tightness. You know, a lot of energy will leak in and out of a building strictly due to how well the building is sealed up. Even if you have good insulation and you have good windows, if the sealing is not done well, that's where a lot of the energy leaks out. So air sealing is something that's very important. So that's on the architectural side. Then within the building, once we have a very tight envelope and we reduce, you know, the amount of heating and cooling that we need to do, the next step is to do, you know, the amount of heating and cooling that we need that's you know, left over from what we couldn't do with the envelope, and do that in the most efficient manner possible. And so that's when the HVAC system comes into play, and I'll touch on that in a second. And then, you know, the two big things that we look at for an efficient electric HVAC system is heat pumps, and I'll put heat pumps as kind of the overarching technology. There are geothermal heat pumps and there are air source heat pumps. And we're planning to use both on this project, and I'll get into the detail in a second. But heat pumps, by definition, they use electricity to make either heating or cooling. You think of a refrigerator, it just, you know, it cools the inside of the box. And whether you realize it or not, it's you know, in a small way, heating your house. So it's cooling the inside, heating the outside. If it were a heat pump, you could reverse that process. And so whether it's air source, meaning it's just using the outdoor air to exchange energy, or geothermal, where it's using the ground, they're both essentially doing the same thing. And it's important to use heat pump technology because heat pumps are 3 to 4 times more efficient than burning fossil fuels, or, for example, electric resistance, like electric baseboard heat, like you might have in your house. The other technology we utilize that's extremely important is energy recovery. Unlike maybe your house or a building that you're familiar with, a middle school, high school has a lot of ventilation air being brought into it the entire time the school is occupied. So that's fresh ventilation air to make sure that, you know, indoor air quality is where it should be, you know, student health is being maintained, you know, levels of alertness in the classroom. No matter what we do with the architectural envelope, a lot of ventilation air needs to be brought into the school. And consequently, there's the stale air gets exhausted out of the school. So one way that we save a lot of energy is to use energy recovery on the exhaust air we bring out of the building. So we're not just, you know, we heat all that air coming in at 70 degrees in the wintertime. If we just exhausted it out with no energy recovery, that's a huge waste of energy. It's kind of like going right out the chimney. So we have energy recovery on our ventilation equipment that kind of keeps, you know, 70 to 80% of that energy back in the building. So that's kind of, those are the two major technologies on the HVAC side of things that we're using to really kind of lower our energy use. And then the final piece is to, again, put those PV panels on site somewhere. And so if we go to the next slide, I'll get into just a little more on all of this. Here are just kind of some, you know, simple diagrams of what the two technologies that we're looking at for this. And Ben kind of alluded to the fact that our initial thinking prior to seeing the most recent costs for school construction was to do 100% geothermal. Geothermal involves, as some of you may or may not be familiar, drilling extremely deep holes in the ground, essentially. And it's not like a well for well water for your house that's maybe 20, 30, 40 feet deep. A geothermal well is, you know, somewhere in the 500 to 600 foot range. And for a large school with, again, even if we're doing an energy efficient school, it's a relatively large energy footprint. It requires quite a few geothermal wells, and drilling them costs a lot of money. And unfortunately, the cost of geothermal in particular, again, because it's being utilized more, has gone up quite a bit. And so what we found through the cost estimation process is that drilling enough geothermal wells to take the entire heating and cooling demand of the school was essentially prohibitively expensive. And so the proposal is to use, okay, if we cut the geothermal wells in half, roughly, that saves a large chunk of money on the construction of the school. And so we still have half of our HVAC using geothermal, which is, the absolute most efficient way to heat and cool. The other half is using what we call air source heat pumps. So still utilizing a heat pump technology, and air source heat pumps are not quite as efficient as geothermal, but they're pretty close. And so we're not really sacrificing, we're not taking a huge energy penalty in doing this. It's just, it's on the margins. So we essentially have half of our equipment is air source geothermal, half of our equipment is geothermal. That also kind of gives us a side benefit of having some diversity in the type of systems that we have. It ultimately still gives us a very low energy school, and then saves us money on drilling, essentially, dozens of geothermal wells that, the project budget, we don't feel would be able to support it. So let's go to the next slide. And then the other technology, and this is just a diagram here of energy recovery. And people are often surprised by how much energy it takes to ventilate a school, for example, or any building that has a high ventilation load. So what this is we have, fresh outer air coming into the building, stale exhaust air going out of the building, and then we run both air streams through a wheel, and that wheel is slowly rotating. And what it's doing, it's not allowing the air streams to mix. So the fresh air is still fresh, the stale air is still stale. They're not mixing between each other, but the wheel allows heat transfer to happen. So the warm air that's leaving the building warms up the wheel rotates and passes that on to the cold in the example of winter that I'm using. The cold air coming in gets warmed up, and you essentially can save 70 to 80% of heating just from this one technology, which uses very little energy. So that's everything that we're doing on the ventilation and exhaust side for the entire school is utilizing this technology. So it's a big chunk of energy that we're able to save using this technology. All right, we'll go to the next. And so getting into a little more detail here on the kind of the half and half, we have essentially 70 to 80 geothermal wells that we're proposing that would go under, essentially under the parking lot. And the beauty of geothermal is you drill the wells, you can cover it up and you never see it again, and it's buried under the ground and it kind of does its thing. It lasts a very long time. The 70 to 80 number is where we landed at in the kind of this hybrid scenario with, half geo and half air source. So some of our HVAC equipment would be what we call geothermal condenser water, HVAC. And then the other half would be these air source heat pump units. All of the units would be up on the roof. They would be delivering fresh ventilation, cooling, and heating air via ductwork down to all the spaces, whether it's classrooms, the auditorium, cafeteria, gymnasium, all the offices, all of the spaces in the school in some way would be fed by either geothermal heating and cooling equipment or this air source heating and cooling equipment. And then, we're able to do individual temperature control, individual ventilation control throughout the school with this technology. We'll go to, I think, the last slide. So, and I'm going to throw a term out here some of you may heard. There's a metric called EUI, which stands for energy use intensity. And think of it like a miles per gallon rating for your car. So again, the lower the number, actually, unlike a car, the lower the number, the better for a building. So energy use intensity is just the energy use of a building over an entire calendar year divided by square feet. So it allows you to compare energy use, for example, of a larger high school compared to maybe a smaller high school. With everything that we talked about before, getting to an efficient building design, we're looking to get the total EUI of the building somewhere around 25, and that's in kBTUs per square foot per year. Just for reference, the existing school is somewhere north of 80 or 90, and that's a school that's not fully air conditioned, and most of that EUI energy is fossil fuel heating. So we're already kind of in a, definitely in a place we don't want to be. The newer school would be all electric at somewhere around 25. And the reason we target that 25 number is it would take a lot of solar panels to fully offset the energy use of the school, even at 25. So if we're too much higher than 25, if we don't do a good enough job with the envelope or the HVAC systems, it just becomes prohibitively expensive to buy all those solar panels and just find real estate to put them. So the idea is get to 25, have an all electric school, and then whether it's now or in the future, get solar panels on the roof or elsewhere on the site, so that we ultimately get to that net zero. But the really important part to drive home is that the first job is getting the building and the architecture as good as it can be, getting our HVAC system as good and efficient as it can be. Those are kind of the long life, 30, 40, 50-year life, lifespan products of the building, and then adding the solar panels on top of the building, whether it's now or a few years in the future. That's something that can happen later. But getting the building design right, getting the HVAC design right, that's something that we need to get right for day one. And then again, solar panels could come in a later time frame.
Awesome. Thank you, Eric. Eric, I wonder if you could speak to some of the, I was showing a slide earlier that came from this summer. I don't know if this is current information. I think we're in the 2A column at this point, aren't we?
Yeah, and the hybrid we ended up is a little bit different. I mean, there's different ways to mix and match geothermal versus air source heat pumps. And we're actually doing it, with some, again, feedback from the contractors and just talking amongst ourselves. So the option we landed at is not exactly any one of these options, but yes, okay. It's closest to maybe 2A, with a little bit of 1C in there. But yeah, so if you look at this column here, up at the top is this, I call it little p EUI. You see over on the left-hand side, the p EUI, P stands for predicted range. We estimate that system would get us in the 28 to 31 range, whereas an all geo system would have us a little more comfortably closer to that 25 number we're trying to get. Again, these are early numbers, that we're estimating, and we're estimating them hopefully on the conservative side, meaning they're a little higher than they might actually be. We would still work to get that down as close to 25 as much as we can. But yeah, that's kind of the 2A column is kind of where we're floating as far as energy, first cost, energy cost, maintenance cost. So you can kind of see how this shakes out. And again, these are kind of early estimate numbers that we were all working with and putting together. But you can see this is kind of the level of comparison contrast that we did, to kind of get to where we got. There's a lot of analysis, and a lot of, we do this on many projects, trying to find the right mix for this school, for this site. And there's a lot of factors.
Yeah, I thought one of the most compelling things, and there were a number of factors that we looked at when we were selecting the HVAC system, but was the savings, the actual dollar savings. And I think this is a little different from what it's been historically. I think maybe 10 years ago, you can tell me if I'm wrong about this, but from what I understand, it was at one time, a lot more expensive if you wanted to kind of go green, right, to be sustainable. But given the kind of the savings in the rising cost of fuel oil in particular, you can see that the existing building there on that total cost, and this is a 40-year event horizon, would be around 55 million because you have a ton of energy cost. But you contrast that with the closest thing that we're looking at here is this column 2A, and you're looking about an $18 million savings over that time frame, which is pretty cool, right? And speaking of pretty cool, the new building will have air conditioning. And as we think about climate change, that's going to be pretty important, considering that the old building does not. And we'll see students, in the fall and in the springtime, in a building that's probably going to see some days that are well north of 75, 80 degrees. All right, why don't we pause there and see if people have questions.
Great. So
I got a quick question. Sorry, Heather, for jumping in.
Oh, that's okay. Go ahead.
Hey, that spreadsheet that you have up there actually shows the geothermal less expensive than the air source combo. Is that just because it hasn't been updated, or?
No, I think that's accurate. It's because of the efficiency of that system. Eric, you had explained this at one point. I'm trying to remember, but I think it's the fact that the the heat pumps have a shorter lifespan, isn't it? That they need to be replaced. See this replacement cost here. Whereas the geothermal, the expensive part of that is digging the wells, and once you have them, you're pretty good. The other components aren't quite as expensive. But I'm over my skis here, as I've
yeah. Well, I'll try and get you back. I love a good skiing metaphor. I'll try to get back on the skis. No, it's a great question. And just if everyone looks at that total cost line, 2 rows up from the bottom, this is what we call a life cycle cost analysis, an LCCA. And this is looking, we did a long life on this. Often a life cycle cost is a 20-year, maybe a 30-year. We decided to look at a 40-year life cycle cost comparison. The existing school is well over 40 years old. So it's likely that the new school is certainly going to be in service for 40 years plus. And so, really thinking long-term, as we all should be doing with our buildings and with our environment. The total cost, as you bring up, is the least expensive for the all geothermal option. The rub is that if you look at the second row down from the bottom, first cost, this is the construction cost. And what we all have to come to grips with, even though over the long term, a fully geothermal system may cost less money to everybody overall, that's a 40-year horizon. We're all going to get very laser focused on this for, what is it going to cost to build this school? And these numbers are before we had the actual cost estimate from PC Construction. So, but if you look at the first cost of, let's say the all geo, the 1B, which is the one that we were going with, is 14.2 million versus 2A, which is at 12.6. Round numbers, that's a $2 million difference between the hybrid versus the all geo. In reality, the numbers we got, the difference was more like 4 million. So yes, if you spend $4 million extra today, you will eventually make it back over 40 years, but you still are faced with the problem of how do we get the $4 million today? And so that's kind of where we land with this. And so it is true that, at least in our estimation, all geo would be the least expensive long term. But the hybrid system is a close second.
Thanks, Eric.
Thank you. Perfect.
Great, thanks you guys. So for everyone who came into the meeting partway through, I just want to let you know we're taking questions in the chat. So you can type your questions in there. If you haven't used Zoom before, go down to the bottom of your screen and there's a menu there on more, and chat will be at the top of the menu that opens up, and you can open the chat and type directly into it and we'll take your questions from there. So we've got our first question from Linda. Is the school intended as a shelter place for the community in case of a disaster? If so, in case of a power failure, is there a stand generator system thought of?
I believe the answer to that is no, that we are not an emergency shelter facility. And I apologize that I don't have as high of a confidence interval on that. I know there have been discussions about getting that designation at some point, but my understanding is that it's not.
And to answer the generator question, there is a plan in the design to have an emergency generator to be able to back up the heating system as much as we can. But as you might imagine, an all electric heating system requires a lot more backup power, to back it up, unlike a fossil fuel boiler, which again burns a lot of fossil fuels. That part you don't need to back up. You just need to have a small electric load for the boiler electrical, which is very small, and then the pumps. And so there is some plan that we're working on to, have generator power, but to what extent? And to the point of the question about a shelter, I'm not sure on where that will land.
Yeah, this is Todd. There's also been discussions that the town is getting 3 electric school buses that could be used as backup generation and tied into the system. But it sounds like you guys haven't really heard about that yet.
No, we have that. Our finance manager is kind of a godsend. He's been with us for a couple of years. He came from the New Hampshire public school system, where he spent a career and maxed out the system and was looking to keep working for a few years. And at one stop along the way, even before that, he was the finance manager at Cardigan Mountain School, where he did a solar install, right? So he's got a lot of background with this, and he's been good with the project. Another thing he's great at is grants. And when the Biden administration was giving incentives for green school buses, he jumped on it and wrote a grant, and we got it. And so we got funded for, I thought it was 2 of the green school buses. But maybe we have plans to get 3, but federal funding for that. And that's pretty exciting to see a couple of green school buses, you know, bumping around with the Mountain View's name on them. That'll be here in about a year, I guess.
Great, thanks you guys. Our next question is from Peter. If accounting for net zero with the panels installed, does that mitigate, reduce, eliminate the lifetime energy cost?
Good question. The comparison we looked at on the slide, looking at the different potential HVAC systems, that did not factor in PV production. At the time, we were assuming, at least for this exercise, that photovoltaics would happen at some point in the future, and that they wouldn't be on the building, as we say, day one that it opens for use. And so this is just looking at, you know, the raw cost of energy and everything else of the school with these different HVAC options with no PV panels. So that's a good question. Accounting for PV production, again, if we're truly net zero, and again, these options, you know, it's a little easier to get to net zero with the options with a lower EUI, and slightly harder to get to net zero with the options with a slightly higher EUI. But if we ultimately did get to a place where we got to, you know, certified legitimate net zero with PV panels, your energy cost would be zero, you know, essentially. So, you know, whatever year those get installed, there might be a few years where you're paying for energy. And of course, if any of you happen to have a net zero home, maybe you don't, that's, you know, not too many people do, but a gentleman in our company does have a net zero home. You still do get a bill from the electric company. They will always get some money out of you. So there will be some small amount of money that the school will pay to Green Mountain Power. But then the energy usage part of it will be zero. So short answer is no, PV is not factored into these numbers that we're looking at.
When we've got, if the question is kind of what's the plan with the PV panels, and how many do you need, and you know, to get to net zero, the discussions you know, over the summer, I think we identified that we would need about a 6 to 8 acre solar farm, and we've had some interest in you know, some adjacent properties. And that's exciting, but you know, that's all kind of future and TBD. In terms of how we'll, you know, kind of achieve that, but that's in the plans for sure.
Great. So Linda asks, is the cost for a backup generator part of the 99 million?
Yes.
Great. John asks, the school is right next to the river. Any thought of using water source geothermal?
I don't.
Yes, we did think of this, and there's a 2-part answer as to why it's, you know, to not feel like I'm nipping it in the bud too bad, but it's not feasible. One of which is, I believe Vermont law essentially prohibits, you know, it's is it Act 250 or the Waterways Act. We just can't have permanent construction in a river corridor, and so even if it's just piping, that would violate the act. And then the second piece is from an environmental standpoint. That would, even though it's a flowing river, it would, you know, heat up the river and cool down the river depending on the season. And so there would need to be extensive environmental analysis to make sure that it's not adversely affecting, you know, fish and wildlife in the river. So, you know, it's always so tempting to look at something like that and say, oh yeah, we can just put our loops in the river. And if any of you are familiar with Cornell, it's not a river. Cornell has a very deep lake, and that's part of the reason why it works well. Cornell has what they call a pond loop system, pond loop geothermal, that again went through extensive, you know, biological studies and reviews, and ultimately it works because it's a lake, it's huge, and it's very deep. And so whatever they're doing down at the very bottom of the lake, temperature-wise, you know, whether they're heating it up or cooling it, it has, you know, I guess minimal enough effect on the ecology of the lake that it's not going to adversely affect it. So I think a couple reasons why, but it's not, it sounds like it should be a great idea, but it's not feasible, I think, for this. And I don't know if Ben or Todd, you can elaborate on Vermont law on that aspect, but.
No, I can say as part of our Act 250 permitting processes, we did a whole site plan around drainage, and we looked at we had some folks from the Vermont Natural Resources Department came out and did a whole study of the river around. It was really focused on endangered species, and they identified 2 or 3. I think there were 2 plants and 1 reptile or amphibian that they said, yeah, you might want to be concerned here, but your plans, because you're staying away from the river, you're okay. So that was as far as our kind of investigations took us on the legal front.
Great. So Linda says, what is the life cycle cost of the PV panels? And thanks for hosting the meeting.
So life cycle cost, it's a good question. We did not study. So again, for net zero, so I don't know that we have a breakout cost for the PV panels themselves. It's not, and Ben, you can clarify this. I don't think PV panels are not in the $99 million figure. That would be a future cost, and you can correct me if I'm wrong there. So we don't have a life cycle cost number for the PV panels, but maybe to the question of, certainly life cycle, a PV panel itself can last, 20, 30 years with, minimal degradation. There's other parts and pieces of a PV system, namely the inverters that, convert, the DC electrical current into AC current that the building can use. The inverters, tend to need to be replaced after 15 years. But, the majority of the system, which is the panels themselves, certainly last 30 years, possibly longer. And so they definitely have a good lifespan.
And we've talked about, we haven't, entered into discussions on this, and we'll need to do some evaluation. We have a member of the board, Matt Stout, who does large scale solar installs in his day job. And he's certainly been speaking with our business ops manager, who's kind of, handles the financial aspects. But one of the options that we talked about is entering into a power purchase agreement, leasing the roof to a third party who could take advantage of, some of the, the credit programs and things like that. But those are all kind of TBD at this stage of the game.
Great. So Ginevra asks, how long will the new building last?
Yeah, our architect talks about it on a 75-year time frame, which is wonderful. It'll be stick built, and it's flexible. So it's that's the plan.
Great. So John asks, a lot of glass in this building. What window technology are you using? What are values in the walls and roof are you designing to?
Eric, do you know?
I don't know. That's a great question. I don't know offhand. We are above code. And so I'll caveat that by saying energy codes have gotten better and better. And it used to be, if you were designing a code minimum building, it was kind of a bad thing. Like you were doing the bare minimum, not going the extra mile. Energy codes now are quite stringent, at least what they were 5 years ago. And so even with that, we are, I think, slightly above what the energy code mandates. The glass specifically, I don't know, but the unfortunate thing working against us is triple pane glazing, which is about as good as you can get. High performance is also extremely expensive. And so I think we're trying to use triple pane glazing in strategic areas where it has the highest impact. But I don't quote me on this. I do not know what level of U value we have in the project, in the current moment, but we're better than code, and we have it, as good as we can get within essentially the budget we're working within.
And I could say that it's interesting. And if we get into any of the financial aspects, I think I mentioned in the overview of the project that we did bring on a fundraiser, and we've had a pretty significant amount of success in raising funds in the 18 months or so that we've been at that. We're hopeful, or we're encouraged by the fact that there are a number of potential donors who we've spoken with. First, there's a lot of interest in sustainability and achieving net zero, and a good share of our donors have made targeted gifts to help the project achieve those goals. But we're hopeful that, there are some donors who are, it's a public school. It's unusual to do private fundraising for a public school, and some are kind of sitting on the sidelines. And if we were to get, a major gift once the bond passes, or to keep at it, there could be some upgrades we could make. We just would need to have those gifts in time to change the plans. And I think that we probably are looking at maybe a 6-month window after the bond passes to be able to make that kind of a change, whether it's, changing to full geothermal again, or, upgrading the windows if we've kind of scaled back the version that we're going to be using.
So John is asking, what is the cost and hardware to get from net zero ready to net zero actually?
I think it's all about the PVs, isn't it, Eric?
It's about the PV panels, and just, super rough math. Again, this is very rough math, but, back of the napkin to keep in your head. The cost of installing a solar panel system, and Ben, you could certainly, check this with the gentleman who does this in his day job at some point. But we talk about $3 per watt of solar panel capacity installed. And so I forget what the total wattage or kilowatts we were thinking of for this building.
Is it here on the bottom row? This square foot of PV and cost for net zero?
You know what? It is there. Wow, I had that on there. I didn't even remember. So thank you.
Now this isn't exactly the what we landed on, but I think it's in the ballpark.
Yeah, but that gives you an idea. It's in the few $1 million range. So again, it's we already worked hard to kind of cut $4 million out of the HVAC side of things by going to hybrid geo. If you put 4 million back in, you could get to net zero. But PV is something that you could do later, whether it's a future grant, future donation. You don't have to tear apart the building to put PV in the project, whereas HVAC, you would have to tear apart the building to get an entirely new HVAC system in. So the thought is, if the project can't support it, day one, just to get, the good school that we want, the stuff that we can't do later, which is the architecture and the internal systems, PV is something that you would do later. And so that's kind of, or has been alluded to, a power purchase agreement, which is, kind of a zero initial cost, and then it's a different kind of financial arrangement. But yeah, down there on the bottom row, that gives you kind of a rough, 3, 4, maybe north of 5 million, depending how things shake out, additional cost for full net zero.
Great. So John asks, does the building have to conform to Vermont's commercial building energy standards? If so, I understand that standard has been updated and goes into force July of this year. What cost bump might that entail?
So yes, it does have to conform to that. And I think that we already, we will conform with that new standard as is. I don't think there's going to be a cost bump for that. But I need to double check, do my homework on that, but I believe that to be the case. We have a better than code building as is, so better than the current code.
And Karen asks, a green drink presentation back in December raised the idea of geothermal networks shared by buildings near each other. It sounded like the Union Arena might be a promising connection in this regard. It sounded like output from the arena would be useful input to the school. Can anyone reconstruct the logic of this and speak to its feasibility?
So short answer is yes. I mean, it needs to be studied a little further. And, the first thing we would want to do is get some, some utility bills in whatever form we could from the arena. I think what we would propose to do, and you can kind of see in the image, the parking lot on the right side of the screen there, that's roughly where the geothermal wells would go. And yeah, there's a good view of it. So those 70 to 80 wells, we would need all of them to serve the school and the loads that we need. The ice rink could certainly tap into it. And depending on the way the different loads shake out, if you think of geothermal, it's just using the earth like a battery. So you think of maybe your iPhone, you're either using your iPhone draining the battery, or you're plugging it in and you're charging it back up. We're doing the same thing throughout the year with temperature. We're either, cooling the earth down or we're heating it back up depending on the season. And there's a certain amount of, energy hours, if you will, just like kilowatt hours that we're, so, you're depositing energy into the ground or extracting it. And ideally you do equal amounts of both throughout the entire year. And so if our ice arena, helped us get to more of a balanced, and I'll say you never get to perfectly balanced. It's almost impossible. You just try and get as close as you can. If the ice arena were able to tap into the same 70 to 80 bores, geothermal bores, and help us get to a more balanced situation without, taking energy from the school, it could be a great option. So I think, as this moves forward, I think that's definitely a great thing to study.
Well, that's interesting. So as we're trying to heat the building during hockey season and keep the arena cool, that's kind of a good match there. Is that what you're saying, Eric?
Potentially, yeah. I mean, it warrants further study. And people might not think it makes sense, but even in Vermont, with the building that we have and the internal loads that you have in a school, as we've currently estimated it, the school is what we call a cooling dominant building. So the majority of energy going into the school is actually cooling energy, not heating energy. And so, it's unlike the current school, which is, entirely heating dominant.
So John asks, will the glass curtain walls in the hub of the building be insulated glass, ballistic glass? What is the ratio of glass to wall for the building envelope?
Also a great question. I don't know off the top of my head. It's low. I mean, I know the architect has used glass strategically, again, for that, that central kind of gathering area, eating area, again, having, views out to the river, but elsewhere being, very conservative with it. It doesn't take a lot of glass to give you the daylight that is helpful for learning and student engagement. That's the whole other side of this, aside from the energy and sustainability is, health and wellness and student performance and all of that good stuff. So I think, there's been lots of testing. I know that, the architect has been doing on getting glass where it has the most impact, but minimizing it from an energy standpoint. So the exact ratio, I don't know off the top of my head, but we could certainly follow up with that.
Great. If anyone has any last questions, you can go ahead and enter them into the chat. And we will be sending out this recording via YouTube. So Ben, are there any dates you want to share if people are just watching this as a recording but want to come to an event and ask more questions?
Yeah, let me stop my screen share and actually they were published in the Standard today, our remaining roadshow dates, and I don't have my copy right next to me, but I do know that we're in Killington on Monday evening. Let me grab the time here. Just go into my calendar. Yeah, so Killington Select Board is going to be 6:30 at the Killington Public Safety Building on Monday the 22nd. At the Barnard Town Hall, that'll be 6 o'clock on Wednesday the 24th. And then let's see, the following week, we have no dates, it looks like, not until February 12th. We'll be in Reading at 6 p.m. at the Reading Town Hall. And then the next day will be in the Teagle Library at the Woodstock Union High School. That's at 6:30 for those who are in and around Woodstock. And our last event is in Bridgewater, and I believe that's on the 27th, but I'm not seeing it on my calendar. February 27th. Yeah.
Great, thank you.
Sure.
So John asks, does the architect use any thermal simulation software for the building design?
Thermal simulation. Do you know the answer to that, Eric?
I believe so. I mean, so we do full, energy loads. And so we certainly simulate, to do our heating and cooling load analysis. And then we also do energy modeling, which is essentially a virtual model of what we expect the building to use energy wise. That's how we kind of do our estimation of, total heating and cooling energy, and then, amount of PV panels to offset. So yes, we do that. And it's kind of, right now it's a little bit more on the rougher side. And as we get further into design and more detailed design, we do a further refinement of that. But short answer is yes, we do use energy simulation software. It starts off a little more rudimentary and then gets more refined as the process goes through.
We have another question. Ben, when are your 2 school tours?
Yeah, I have to dig through my emails. We've had some discussions about that, and I think we picked some dates, but I apologize. I'll have to follow up to let you know when those dates are.
No problem. We can actually, if you want to send those to me, we can send them out in the follow-up email so everyone has them.
Sure.
Great. Any last questions? And I'll just also share, for those of you who didn't join us at the beginning of the talk, our next Green Drinks will be an in-person event on home electrification at the Norman Williams Library with the Vermont Energy Education Program. And that will be on Saturday, February 24th. So I hope you can join us for that. Let's see, it sounds like we have a message from Carrie saying the tour is January 27th at 9:30 a.m. So we can verify that and send out the dates in the email for everyone.
Thank you, Carrie.
And again, on February 7th at, I don't have 6:30. Is that 6:30 p.m.? Thanks, Carrie. Great. Thank you so much for joining us and sharing so much great information, you guys.
Sure, it was a pleasure.
Yeah, likewise. Happy to speak to it.
Great.
And thanks to Sustainable Woodstock for being a part of our process. Michael Caduto was great in our sessions and was a real asset in getting us where we are.
Yep.
And we're looking forward to working with Todd from here.
Yes. All right.
Yeah,
thanks for everyone.
Yeah, thanks for your time. Appreciate it.
Sure thing.
All right. Good night, everybody.
All right. Good night.